Okay, this is lecture 3. The last time we touched on lecture 2, where I introduced to you what machine learning is, the need for machine learning. I gave the definition of what machine learning is and the machine learning process itself. Excuse me. In today's lecture, we're going to talk about the types of machine learning. I'll give you the examples that exist in each of the various types of machine learning, which is supervised, unsupervised, and reinforcement. Then I'll talk about the differences amongst all these three, after which I will introduce to you the type of problems that could be solved using machine learning. And in this case, I'll begin with supervised learning algorithms. As you can see, these are some of the ones that have been outlined in here. All these are some supervised learning algorithms that we're going to go through today. Now, let's go to lecture 3. Now, I'll begin by telling you the types of machine learning that exist. So let's start. So now it's time to learn about the different ways in which machine learning can learn. It can learn in so many ways. So let me move ahead and look at the types, for you to look at the types of machine learning that exist. Now, this is the most interesting concept in machine learning. There are 3 different ways in which machines learn. There is something known as the supervised learning, the unsupervised learning, and finally, we have the reinforcement learning. So we'll go through all of these one by one, and I will make sure you understand what supervised learning is first, and then we will look at the other 2 types that exist. So by definition, supervised learning is basically a technique in which we teach or train the machine by using data which is well labeled. So the key word here is the data that we have is a labeled data set. So now, in order to understand what supervised learning is, let us consider a small example. So in this case, you remember when we were kids, we all needed some sort of guidance to be able to solve some mathematical problem. A lot of us had the trouble solving math problems. And even now, most of us find it difficult to solve most of the math problems that we're given in school. So in this case, our teacher always help us understand what possibly addition is, or basic mechanics is, or any of these calculation is, and how we'll be able to tackle a mathematical problem. So in a similar vein, you can also think of supervised learning as a type of machine learning that involves a guide. So the labeled data set is a teacher. In this case, that will train you to understand the patterns in that particular data set. So the labeled data set is nothing but the training data set. So I will find a way to explain to you more about this as we move along. So in order to understand what supervised learning better, let's take a look at the figure that we have on the screen here. So right here, we are feeding a machine images of Tom and also Jerry. So this is a labeled data set, and we are feeding the machine images of Tom and also Jerry. So the goal here is for us to be able to, for the machine to be able to identify and also classify the images into the various classes that we have. In this case, we have Jerry class and also the Tom class. So these are the 2 classes that reside in our data set, or in the example that we see on the screen. So one will contain image of Tom and the other will contain image of Jerry. So now the main thing here is that we need to note in supervised learning, it's a training data set. The training data set is very key in supervised learning. It's actually the training data sets that we're going to use to be able to, help us build our model, and we use a test data set to do the classification to see how accurate our data set is. So in this case, the training data set is going to be very well labeled. So now what I mean here is that the training data set has all these classification given. Per previous example, I said for a labeled data set, you have all the predictor variables, coming together to give you an instance of the target variable, which is in this case the labeled output. So that is how it is. So in this case, what we are doing here is we are telling the machine that this is how Tom looks like, and this is how Jerry also looks like. So by doing this, you are training the machine to be able to label the data. So that's the main thing that you'll be doing here is to label every input that goes into the machine to help the model make a very good prediction in here. So this is very key when it comes here. So you can see this is a label data set. We have all these known outputs and we feed it. Of course, we have to do data cleaning. We've gone through all of these things. Then we feed together with the algorithm, we'll be able to come out with a model and use a test data sets to combine these algorithms, to combine. Once we have a model built, then we're able to use a test data set to see how good our training model is in terms of the classification. All right. Okay, so with supervised learning, the key word here is we will be working with a data set which is labeled. So we have a labeled data set. By labeled data set, we mean to say this data set has an output that contains either a list of all the categories of whichever tuple will be would yield that particular target variable. So that is a supervised learning. So it's a technique in which we teach or train the machine using a data set which is well labeled. Now let's talk about the second one, which is supervised learning. So we will examine the same example to understand how unsupervised learning operates. So what exactly is unsupervised learning? So it involves training by utilizing unlabeled data or data sets and allowing the model to operate on that information without any guidance. So like the same suggestion that we gave here, there is no supervision involved. Like the way it is, as the name says, it says unsupervised learning. So it is obvious from here that there is no supervision in learning in this process. So like the name suggests, there is no supervision involved when it comes to unsupervised learning. So think of unsupervised learning as a smart kid that learns without any guidance. So in this case, in this type of machine learning, the model is not provided with any labeled data set. The model has no preconceived knowledge, such as a distinguishing differences between the image of Tom or the image of Jerry. All it does is instead of this, it's actually discerns the patterns and the difference between these types of data points. In terms of data points, we mean the output that we do have here. So in this case, the machine identifies an image as Tom and then provides the output affirming it as Tom or Jerry. So in the same way as you know, for unlabeled, when we have an unlabeled data set, once it's worked on supervised learning, then it means we don't have target variables. So there is no way we have the output of each of the records. So the only thing that happens is we run the unlabeled data sets, which does not have a target variable, together with the algorithm or the classifier, and we build our model. And what happens is for unlabeled data sets under supervised learning, our algorithm now goes into the data sets and look out for features that look similar and group them. Once the grouping is done, we always would have what we call clusters. So you can see based on the features of these two individuals or these two animals, there has been some sort of groupings over here. So we have Jerry here and we have Tom over here. For supervised learning, we should always have a target variable. That is what makes it actually a labeled data set. For unsupervised learning, we don't have a labeled data set, so it means we don't have a target variable. So what the algorithm does is we dump the algorithm inside the data set, we build our model, and all the time the outcome is going to be clusters. So clusters will be formed and feed group of objects or group of animals in this case that have the same features are grouped together as one. That is how come we have these two. So that is the difference between unsupervised learning and also supervised learning. We have a third instance where we call it the reinforcement learning. So when we shift our focus to the last type, which is the reinforced learning, what reinforced learning does is it significantly differentiates itself from the supervised and also the unsupervised. So in this case, reinforcement learning is a subset of machine learning where an agent is usually placed within an environment. The agent learns how to navigate and behave in that environment by executing specific actions and observing the rewards or the consequences that is derived from those actions. So to better comprehend or understand reinforcement learning, we normally consider the scenario of being dropped off on a secluded island. Initially, there might be no sense of panic, but over time, you adapt to the environment, gaining an understanding of the climate condition available, climate conditions that exist on the island, the available food sources that exist, the potential dangers that could be present at the island, and so many more. So this analogy actually captures the essence of how reinforcement learning functions. So generally in reinforcement learning, an agent, in this case, with the example where you are in an island, an agent in this case is placed in an unfamiliar environment. The agent learns by actively exploring and performing actions, then results in either reward or consequences. So eventually, the reinforcement learning is commonly applied to advanced machine learning domains. And this could be like self-driving cars and also the AlphaGo game that exists. So we can also relate reinforcement learning just like how a baby grows. So usually when a baby is born, they have no knowledge of this world. So as they grow, they make mistakes. They learn from the mistakes. They get hurt. They learn from the hurts and know what to do next. So that is how reinforcement also works. Okay, so in summing up, all what reinforcement is, it actually stands as a powerful paradigm, especially in applications like self-driving cars and also strategic game playing scenario like the AlphaGo, as I talked about. So relying on the dynamic process of exploration, action, and also feedback, this helps complete the overview of the main types of machine learning that exists. There are three main types of machine learning: supervised learning, unsupervised learning, and also reinforcement. With supervised learning, that it means we're going to help train the model. We'll do that by the usage of a data set which is labeled. If you say the data set is labeled, then it means it has a target variable. And by having a target variable, we have a list of all the outputs of the instances or tuples or the records that goes in each of the data sets. So that is how supervised learning is. For unsupervised, there is no knowledge of what the data set is. And in this case, the data set does not have a target variable. So by it not having a target variable, that it means when we dump in our model or classifier into the data set, the model that we're going to build is going to now group objects that have similar traits together in the form of clusters. And by reinforcement, this is where the agent has no prior knowledge of the environment that he exists. And in this case, it learns, as you can see from here, it has no pre-knowledge of the environment. So in this case, it learns based on the rewards, based on its action and the rewards that it gets. And if the rewards are positive, it knows which actions are positive and which actions are negative. That is how the reinforcement also works. So before we proceed, let's clarify the distinction between the three types of machine learning. Let's begin by examining the definition of each one of them. So on your screen, you can see I have categorized each of them into definition, the type of problems, the type of data, the training approach, and the popular algorithm that is used in each of these types of machine learning that's available. Now, by way of definition, just a recap on what we just learned. Supervised learning. In supervised learning, the machine learns by utilizing labeled data sets. The model is trained on input-output pairs, where the output is known, serving as a guide for learning. Now, for unsupervised learning, usually it always involves unlabeled data, and the machine must learn without explicit guidance. So in this case, it focuses on understanding patterns and forming clusters within that data. And finally, for reinforcement learning, under the definition section from here, an agent interacts with the environment, producing actions and receiving rewards or punishment based on those actions. So the learning process is characterized by trial and error. So that is the definition for each of these three areas. Now let's move on to the next category, which is the type of problem that can be addressed by each of the learning paradigms that we have in here. So under supervised learning, mainly we use supervised learning for regression and also classification problems. So in this case, the machine learns to map labeled inputs into output categories. So as I've been saying, in this case, the machine learns to map labeled input data to a known output category that exists for that particular data. So in this case, again, each record or each row is linked to an output, which is part of the target variable. For unsupervised learning, still under the type of problem that can be solved, we normally use unsupervised learning to apply. We normally apply unsupervised learning to association and also clustering problems. So in this case, the goal here is to identify patterns and group similar data points without predefined labels. And finally, for reinforcement learning, it's best suited for reward-based problems, where the agent learns optimal actions through interactions with the environment. Now, moving on to the type of data which is being used in the learning approach, that is the third one, the type of data. For supervised learning, it involves labeled data. So it means we have the target variable or we have the output variable in supervised learning. I'm just recapping and reiterating most of it so that you get the concepts right. For unsupervised learning, it utilizes unlabeled data. So it means the data set or the data does not have a target variable. And finally, for reinforcement learning, there is no predefined data sets. The agent explores and also learns from scratch. So there is no data set that's available. The agent would have to now explore and learn from the environment from scratch to come out with um, the right information that should exist for this particular learning outcome. And regarding the training process for the fourth category over here, supervised learning involves external supervision, which is guided by a labeled data set. Unsupervised learning, on the other hand, has no supervision and is provided during the training. And finally, for reinforcement learning, there is also no supervision. The agent learns through trial and error. On the fourth one, on the fifth approach, which is problem-solving approach, of course, it also differs from the others. So for supervised learning, the input is mapped to a known output. For unsupervised learning, patterns are understood and output is discovered through predefined input labels. And finally, for reinforcement learning, we have trial and error method where the agent explore the environment, take some actions, and also learn from the resulting reward or punishments whilst they explore the environment. And finally, we have the popular algorithm associated with each of these. So for supervised learning, the most popular algorithm that is used in supervised learning is linear regression, logistic regression, supervised support vector machine, which we normally term as SVM. We have the k nearest neighbor, which is the KNN, and naive Bayes. These are some classifiers or algorithms that we normally use in building models for supervised learning. For unsupervised learning, we normally use k-means and also c-beams, and there are others that also exist. And finally, for reinforcement, we use the Q-learning and SASAS as an example. So those are the algorithms that exist for each of these categories to build models. So in the upcoming slides, we will delve into these algorithms in more detail. And at this point, I would want us to move on to the types of problems which is being solved using machine learning. Now, under the types of problems solved using machine learning, anytime we solve machine learning, we normally would have an output, our output being a regression, being a classification, or being clustering. So for regression, most of the time, it's usually supervised learning, and we have outputs. The output that we normally come out with for under regression is a continuous quantity. So in this case, we're probably predicting maybe we want to predict, we want to predict maybe the next value in the example I gave the last time, the aviator game. We want to predict the next value that is likely for the plane to fly to. So in this case, we can have our output in a continuous as a continuous quantity. So the value will be a continuous value. So those ones fall under regression. So again, the main aim is to forecast or predict. So the idea is to forecast or predict what will happen, and the output that we normally get will be a continuous quantity or number. Example of these prediction could be being able to predict the stock market, being able to predict the next value of the aviator game. And the algorithm in this case, under regression, most of the time we can use linear regression. So when we talk of classification too, of course, still under supervised learning, we normally use classification. Supervised learning, most of the time, the output that we get would either be a regression or a classification. So when we have supervised learning falling under classification, the output that we'll have will always be a categorical quantity. So it will be in the form of a category. It could be either yes or no. It could be we will not have it as one single value, but we will have different values in there where each of those records will map to. We are still talking about supervised learning. So it means we have a target variable. And the target variable would always be an output, which would be a categorical quantity. So in this case, the categorical quantity can be a yes or no. It could be a male or female, and so on and so forth. So the main aim is to compute the category of that particular data based on the record that is being fed into the model. An example of such classification is classifying emails as either spam or non-spam. So that is under classification. And most times we can also have the logistic regression as one of the algorithm or classifiers that is being used to build a model in the classification area. Of course, that is not the only algorithm that we can use. If you look at the previous slide, you can see under supervised learning, there are other algorithms that we can also use. So it's the same way that goes in there. So finally, under clustering, so most of the problems that we normally use machine learning to solve, the output or the answers that we normally would have would either be a regression, classification, or clustering. So a situation where we have clustering, then automatically it means we are working with unsupervised learning. So in that case, we assign data points into the cluster. So it means we have our data sets which contains so many data points. Those data points are not linked to any output or target variable. So what we can do is to dip into the data set that we have. We put in our algorithm or classifier. Then the classifier is now going to look out for objects or data points that are very similar. So all those data points that are similar to each other are grouped together in the form of what we call the cluster. So the main aim is to group similar items into cluster when it comes to clustering. An example is to find all transactions which are fraudulent in nature. So in this case, we have no idea of the target variable. So we only dump in our classifier. And in this case, the classifier could be k-means or c-means. So those are the algorithms or classifiers that we can use to run on supervised learning. So these are the three main types of outputs or problems that we can solve using machine learning. Regression, that is where prediction comes in. Classification, that is where the output could be categorical, yes or no, spam or no spam, male or female, or clustering, where we'll group our similar items into clusters. All right. So under regression versus classification and also clustering, there is this problem statement that has been outlined in here. So to study the house sales data set and also build a machine learning model that predicts the house index price. So of course, we are going to predict the index price. So it means this is going to fall under regression. So regression always gives us a continuous quantity, or as has been stated in here. We are going to predict the next index price value. And this, of course, will fall under regression. Of course, don't forget, we're saying that when it comes to machine learning, the problems that we can solve would be in regression, classification, or clustering. So with this, we are going to predict the house index, the pricing index. So it means we are going to predict a value. So in predicting a value, then it means it will fall under regression. So this is the data set that we have in here. From here, the string data is providing us the data frame, the number of objects that are available. So from here, we have about 21,613 objects or records or tuples or instances of that data set. And in there, we have predictor variables, 21 predictor variables or 21 variables over here. And these variables are the ones that have been outlined in here. This is done with Python. I'm just explaining each of these classifiers that I've outlined. When all the explanation is done, I will just run you through one of the how to build a model using Python. Just one single tutorial. I'll pick up a data set and use that one to explain. So the 21 variables could be the ones that have been outlined here. So we can have the ID, the date. So all these predictive variables helps us come out with, it's going to help us come out with the prediction that we're going to use. That we're going to predict for the house index prices. So these are the 21 variables that exist. So from here, we will feed a data set into the linear regression algorithm or classifier. And based the moment I told you that when you combine a data set together with a classifier, you end up coming out with a model. Once the model has been created, then it means you can now put in your test data sets to predict the value. So that is how this works. So once we have the data set, we run it through a linear regression algorithm, then it will help us predict the housing index for this example that has been stated in here. So problem statement: study a bank credit data set and make a decision whether to approve the loan of an applicant based on his profile. So from here too as well, you can see, let me go back again for you to see the example that we had. So for the popular algorithms, we also have KNN here and also linear regression over here. Yes, so of course, this one is for a continuous variable. And this one is a classification problem. Although we are using the KNN algorithm, as you can see here, KNN can be used for regression and also classification. From the previous slide that you saw here, we can use KNN for regression and also for classification. So this is logistics regression. Most of the algorithms, we can use them. So in this case, in our case, we are going to base on the applicant's previous, loan acquisition and previous behavior with the bank. We want to find out if the bank is going to approve the applicant's loan or not. So the problem statement here is to study a bank credit data set and make a decision about whether to approve the loan of the applicant based on his profile. So these are the variables or the attributes that make up the applicant. So these are all the variables that make up the applicants. So we run the data set here. So this is a data set. Most of the data set, as I said, can be downloaded on Kaggle. When you go online, you can get some of them in there. So we have our data set here. If we push it to our KNN, that is the K nearest neighbor algorithm, we can push it into it. We get our model, and the model is going to help us to classify whether to approve the loan or to reject the loan in this case. So this is a classification problem. So the only answer choices that are available is to either approve or to reject. So that is what makes it a categorical quantity from here. So that is a categorical quantity. The previous one, it was a continuous quantity because we are predicting the price index. And in this case, we are stating whether to approve the loan of the applicant or not to approve. So it is a categorical quantity that we have in here. So that is about it. So the final one that we also have in here, of course, we are to cluster a set of movies as either good or average based on their social media outreach. We are to cluster. So the moment you hear of cluster, that tells you it's an unsupervised learning. It's only unsupervised learning that yields clusters or groups. So these are the attributes. These are the attributes that we have in here. So we have director books like actor, Facebook, Avatar, Pirates of Water. These are the movies that has been outlined, and these are the attributes or the variables that exist for those movies. Now, this is a data set, so we run it through k-means. K-means and c-means are used for clustering. So please always remember what it means, what algorithm to use when you are thinking of regression, classification, and also clustering. So for k-means is best suited in clustering. So we have our data sets. The data set just contains information about movies and their director, Facebook likes, and so on and so forth. So in this case, there is no target variable. There isn't anything to associate these records to. So what we can do is to now dump this algorithm, the k-means classifier algorithm, into the data set. And the moment it does that, it uses the groupings to put them together to come out with the popular movies and also non-popular movies. So based on that, we will be able to know which movie is popular and which movie is non-popular. Now, so for supervised learning, these are the algorithms or classifiers that we normally talk about: linear regression, logistics regression, decision tree, random forest, naive Bayes classifier, k-nearest neighbor, support vector machines. So these classifiers or algorithms, we normally use it for supervised learning. So please you can't use any of these for unsupervised learning. They are best suited for supervised learning. We're going to go through each one of them. We'll talk about what linear regression is, what logistics through to the support vector machine. I'm going to give you an explanation of each one of them. Then, so you have an idea how the calculations are done. The good thing is when you use Python, you only called an instance of that particular classifier, and you use it in your classification or regression or problem. I said classification or regression problems because supervised learning does classification and regression. I didn't say anything about the other, which is for clustering or grouping. All right, so now let's talk about the first one. We have linear regression. Linear regression is a method to predict dependent variable y based on values of independent variable x. It can be used for cases where we want to predict some continuous quantity. So the prediction that we want to do is a value. Eventually we'll come out with a value. We want to come out with a continuous quantity. So it means the value for the y, which is the dependent variable, will be a continuous variable, which could include decimals. Now, on the graph here, we have the independent variable, which is x, and the dependent variable is possible based on these independent variables. So the dependent variable y, this is the explanation given. The response variable whose value needs to be predicted. The independent variable, that is the predictor variable used to predict the response variable. So the following is the equation to represent a linear regression model. When we were young, or even now, the equation of a line is mx plus c, where c is the constant, m is the gradient. So in this case, if we were to think about a linear regression or an equation of a line, then it means this is the y-intercept. That is where the line cuts the y-axis. That is the y-intercept. Then we are able to calculate the gradient based on y1 minus, or the change in y over change in x, which is m. So in the same way, the following equation is used to represent a linear regression. So we have y is equal to b naught plus b1x plus e, where e is actually going to be the error. The explanation is going to be given in the next slide. So let me go in there so you get it. So let's break this down. To get the key concepts, which is going to be discussed as we move along here. So the type of machine learning problems in this case is a regression problem, and the output is going to be a continuous quantity. So continuous quantity in the sense that the value that we're going to predict is going to be a value which would probably have a decimal in it. So an example is predicting the speed of a car based on distance. And the algorithm that we are using in this case is a linear regression, which is a supervised learning algorithm or classifier. So the classification problem in this case here is we have an output which has a categorical value. For classification problem, I just spoke about, these are the types of machine learning problems that exist. The regression problem, this is a regression problem. When we talk of classification problem, it means the output eventually will be a categorical value. An example is being able to classify the gender, whether male or female, spam versus non-spam. And the algorithm that we normally use is SVM, naive Bayes, logistic regression, k-nearest mean, and so on. For clustering, most times it involves grouping into clusters based on feature similarity. Typically, this is an unsupervised learning. An example is Netflix clustering user based on interest, and also algorithm that we normally use is the k-means, which is most of the time for unsupervised learning. This is just a recap on the regression problems, classification problems, and also the clustering problems. Now let's talk about the situation that we have at hand. So from here, for a real-world problems, the house sales data set, what we normally do is a problem we wanted from what we talked about, we're predicting the house index and the type of regressor, type of output that we were going to get was a continuous output by using the regression, and the algorithm in this case was a linear regression. For a bank credit data, as the example that we gave earlier, the problem was to approve or to reject the loan, and the type of classification that we use, the type of machine learning was classification, and we were going to categorize whether to approve or to reject the application of the applicants. And the algorithm that we were using we could use SVM or k-nearest mean. And for the movie example that we also give, we had a problem. The problem at hand was clustering movies as good or average. And the type was clustering. In this case, we're dealing with unsupervised learning. The algorithm or classifier that we're using is the k-means. So in reviewing what machine learning algorithms, we already have an idea what the supervised learning is, what logistic regression is. So from here, let me just move straight into the math behind the logistic regression. So by definition, we said that a supervised learning algorithm predicting a continuous dependent variable, which is based on the independent variable. So in the case, we have y equals b naught plus b1 x plus e. That was the equation that we have. So we have to note that the dependent variable is the y, and it's supposed to be a continuous variable, while the independent variable is the x. So these are the independent variables, and this is the dependent variable, which is just the value that we're going to get. So the independent variable can be either continuous or discrete, depending on wherever the prediction is going to be. So this is the the linear regression equation. So you can see these are the data points. These are the data points, and it's based on the data point that we've been able to come out with a linear regression line or an equation of a line. So now in calculating the slope, that it means we're supposed to find the change in y over change in x. So that is where we have y2 minus y1 over x2 minus x1. We can pick any of the values, but of course, it's always change in y over change in x. Now, the distance from this data point, independent variable x, the distance from here to the actual distance, which is supposed to be on the line, gives us the error. That is how come we have y equals b naught plus b1x plus e. So the e is the error. The error is the distance from the data points to the actual line that we constructed. So of course, from here to here, this is the error. From here to here, this is also the error. And this is the slope. The slope. So from the equation, we have y being the dependent variable. We have being the y-intercept, which is what we have here, where the line cuts. And b1, which is the slope. And x is the independent variable. And of course, e is the error that exists between the data points and the actual line that is being created. Yeah, so by explanation, we establish some sort of linear relationship between the dependent variable and also the independent variable. So the math behind is the fact that we are able to mimic the equation of a line, which is y equals mx plus c, where the b naught is the y-intercept, b1 is the slope, x is the independent variable, and e is actually the error, as we have stated in here. So in summary, the text provides a comprehensive overview of a machine learning problem types that exist in the real world and an introduction to supervised learning algorithms on the focus of linear regression, as we can see. Now, I'm supposed to come out with a demonstration of how linear regression is being used in Python to predict the value of maybe the stock exchange. But I'm not going to do this now. I want to use one video to explain most of these classifications or classifiers in building a model to predict the accuracy of our model. So we'll talk about this one a little later. Now let's move on to the next type of algorithm that we use for supervised learning, which is logistics regression. So by definition, logistic regression is a method used to predict a dependent variable given a set of independent variables such that the dependent variable is categorical. So the dependent variable in this case is categorical, meaning it's going to be going to have different values like yes or no, spam or no spam. So that is where logistic regression comes in. So logistic regression in itself, as you can see over here, we're using this one as an example. So we're using this scenario to illustrate what it means. That is the logistic regression. So let's suppose that you want to predict whether maybe your sister or brother will get admitted to the graduate school based on her CGPA. Of course, the graduate school, that is after first degree, you can go to do your master's. That is where the graduate students come in. So suppose we want to predict whether any of our family members will be able to get admission to the graduate school based on their cumulative grade point average. So logistic regression is used for predicting categorical outcomes, making it suitable for this classification problems. So we use it, you should know what it is so that you know that it is mainly centered on predicting categorical outcomes, that is yes or no, and so on. So values that are not of a single value, like a continuous value, like what we had for the linear regression. So that is a logistic regression. So the distinction from linear regression is the fact that with linear regression, it is used for predicting continuous quantity, while logistic regression is designed for categorical outcome. So linear regression does not predict in the range of zeros to 1, making it unsuitable for binary classification. That is why we don't use linear regression. It's mainly because it's unable to predict in the range of 0 to 1, but it actually gives us a continuous value. And this, because of that, we are unable to use it for binary classification. That is where logistic regression comes into play. So the purpose of logistic regression is mainly for classification tasks where the outcome is categorical. As I said, example could be yes or no, true or false, spam or no spam, approve or not approve. So in this case, we predict the probability of an event occurring. So the naming confusion in here is that the fact that logistic regression is named due to its primary technique, which is similar to the logistics function. Of course, it does belong to the general linear model class that exists, but is specifically employed for classification purposes. So by definition, as you can see over here, logistic regression predicts an independent value y or independent variable y given an independent, sorry, let me go again. So by definition, as you can see over here, logistic regression predicts a dependent variable y given an independent variable x, with the dependent variable being a categorical value, that's a yes or no. So the nature of the outcome in this case is the fact that the outcome in logistic regression is always going to be categorical. An example of the categorical value or variables can hold values like 0 or 1, yes or no, true or false, spam or no spam. And of course, in terms of the classification to logistic regression is named for its underlying mathematical techniques, and it is used for classification tasks. Now, the key distinction here lies in its ability to predict categorical outcome in a probability range ranging between 0 and 1. So in summary, when you hear of logistic regression, it is a classification algorithm which is designed to predict categorical outcomes. And by so doing, it makes it easier or suitable for scenarios where the dependent variable itself is binary or represents so many classes. So that is about logistic regression. So from here, you can see we have the linear regression equation is equal to y equals b0 plus bx plus e. So represents a relationship between p of x and a probability that y equals 1 given x and x. So in doing so, we take the exponent of the equation since the exponential of the any value is a positive number. And secondly, a number divided by itself plus 1 will always be less than 1. So from the formula that we see here, you can see that if we take the exponential of this value, this is the whole of the numerator is exactly the same as what we have in here. So if this value were to be 1, and this is also 1, and we have an addition of 1, then it means 1 over 2 is always going to be less than 1. So that is why we say a number divided by itself, this number divided by itself plus 1 will always be less than 1. Those that would want to have more information about the calculation of the logistic regression can go through it. And as I said, when we do the demonstration, Python does all these on our behalf and help us in doing this classification and giving us how accurate our model is. Now, still on that, so that is the formula we have in here. Of course, when you do cross multiplication, this multiplied by this, we eventually will end up with this equation over here. So that is about in 1. So it's either yes or no. That is how the logistics regression works. Now let's talk about decision tree.